Section 3.2 is titled Rational Numbers. The first vocabulary term is rational number, and a rational number is any number that can be written as a fraction. So here we have some examples: 0.87, 2/3, -23, 1.5, and -2.56, with the 5/6 repeating. Now, when you look at the decimals, remember we learned in our last lesson how to write fractions as decimals. Today we're going to learn how to go the other way, how to write decimals as fractions. So those two decimals in the examples can be written as rational numbers. So let's write each rational number as a fraction. What's important to note here is that when you are writing a rational number as a fraction, the fraction cannot be a mixed number. So we have to write mixed numbers as improper fractions. So you have to remember how to do that. And some of you know that they call it the candy cane method, where you kind of draw a candy cane on the fraction. You do 6 times 6 plus 1. So 6 times 6 is 36, plus 1 is 37, and we write it over the original denominator, 6. So we write 6 1/6 as an improper fraction, 37 over 6. Whole numbers are really easy to write as fractions. All we have to do with a whole number is put it over 1. -23 can be written as a fraction, -23 over 1. Pause the video here, try the next two on your own. Again, we have a mixed number, 4 2/3, so we want to write it as an improper fraction. 4 times 3 is 12, plus 2 is 14, and we write it over 3. 7, a whole number, we just put it over 1. So remember, rational numbers are any numbers that can be written as fractions. We've just looked at 4 examples, and we've written them all as fractions. So, to write terminating decimals as fractions, we're going to look at the last place the decimal goes out to. So in this example, we have 0.64. Notice it goes out to the hundredths place. If you know your decimal places, this will be really easy. Then what we want to do is take that number, 64, and divide it by 1 and the same number of zeros that are in the digit. Now I know that kind of sounds confusing, but here's what you can remember. It goes out to 2 places. The 6 is in the tenths place and the 4 is in the hundredths place. So we would divide this by 1 and 2 zeros because 64 is 2 digits. So for example, if it goes out to the tenths place, we're going to divide by 10. Notice the tenths place is 1 spot after the decimal. There's 1 0 after the 1. If it goes out to the hundredths place, we divide by 1 and 2 zeros, or 100. So 64 goes out to the hundredth spot. We are going to take 64 and divide it by 100. And the last step is to reduce the fraction. So what you have to remember here when you're reducing is what number goes into both of these evenly. You might start with 2. 64 is even, so is 100. Okay, so 64 divided by 2 is 32. 100 divided by 2 is 50. But you actually can go another step further. 32 and 50 are also both even. We can divide both of those numbers by 2 as well. 32 divided by 2 is 16. 50 divided by 2 is 25. So 0.64, the original decimal, the terminating decimal, can be written as a fraction, 16 over 25. Let's look at a few examples. Let's write each decimal as a fraction in simplest form. So we have 0.84. That goes out to the hundredths place, so we're going to take 84 and divide it by 100. Now we need to reduce the fraction. We need to ask ourselves, what number goes into both 84 and 100? You again could start with 2, or maybe you recognize that 4 goes into 84 and 100. So if we divide the top and the bottom by 4, all we're doing is reducing the fraction. We get 21 over 25. So 0.84 can be written as a fraction, 21 over 25. Number 6, 5.875. Here we have a fraction, but it also has a 5 in front of it. So we're going to ignore the 5 for a little bit first. We know the 5 is going to come into play at the end. So it's going to be 5 plus 0.875. That's the same thing as this fraction, 5.875. We're going to worry about this part first. We want to write 0.875 as a fraction, and then we're going to put the 5 on the front at the end. So 0.875, this goes out to the thousandths place. So we need to take 875 and divide it by 1,000. This is the fraction that now needs reduced. They get a little harder when they're bigger, but that's okay. You may start with a number like 5. 875 is divisible by 5, and so is 1,000. So if we divide them both by 5, you may need to do some long division here. You get 175 over 200. But these numbers are also both divisible by 5. So we can go another step further. Remember, any number that ends in a 5 or a 0 is divisible by 5. So 175 divided by 5 is 35, and 200 divided by 5 is 40. But notice again, both numbers end in 5 and 0, still divisible by 5. We divide 35 by 5, we divide 40 by 5, and we get 7 over 8. We have now reduced the fraction, 875 over 1,000, to 7 over 8. But remember, this isn't our answer because we had the 5 with us. We want to put the 5 in front of it, so we get 5 and 7/8. But remember, when we're writing it as a rational number, we want to write it as an improper fraction. And here, actually, what it says is just to write it in simplest form. So if we're going to write a mixed number and it just says simplest form, this answer would be acceptable. Now, if it said to write it as a rational number, then I would request that you change it to an improper fraction where you do the candy cane method. So for this purpose, when it just says write it as a fraction in simplest form, you can say 5 and 7/8. The last thing I want to talk about are how to classify numbers. All of the numbers that we'll talk about in this course are all real numbers. And real numbers are split into two categories: rational numbers and irrational numbers. We don't talk about irrational numbers as often, but there are some very common ones that you may know. Pi is an irrational number. Square root of 2, that's an example of an irrational number. What you need to know about irrational numbers are they are non-repeating, non-terminating decimals. So non-repeating, non-terminating decimals, those are irrational numbers, which then follows rational numbers are repeating decimals or terminating decimals, because those can all be written as fractions, and we've learned how to do that over the course of the last 2 lessons. So then some of the other terms I want you to know. If we start on the inside over here on the rational numbers side, natural numbers, those are just the counting numbers, 1, 2, 3, 10, 20. Whole numbers are all of the natural numbers, including 0. Integers are all of the natural numbers, so all the counting numbers, all the whole numbers, which just add 0, plus any negatives. And we've worked with integers in our entire last chapter. Then rational numbers are all of the fractions, all of the repeating or terminating decimals. So let's look at classifying some numbers. If you were to write all of the classifications for each number, the first one is 0. So let's go back and look at the chart again. This is something I probably would recommend that you do put in your notes. It'll be handy to refer back to when you're doing your worksheets. So we're looking at 0. First we want to try to find 0 or find what category it fits in. And 0 fits here in the whole numbers. What's important to remember is that any circle or part of this chart that's outside of the whole numbers also is included in 0. So 0 is a whole number, it's an integer, it's a rational number, and it's a real number. It is not a natural number. So we would write whole, whoops, wrong way. We would write whole, integer, rational, and real. Okay, let's look at 1 4/5. 1 4/5 is a fraction. We could write it as a decimal. So that puts it already all the way out here in the rational numbers categories. It's not a counting number because it's a fraction. It's not a whole number, and it's not an integer. So 1 4/5 would be a rational number and a real number. So we would write rational and real. The last number I hope you recognize, 3.1415926535, and it continues on. Hopefully you're recognizing this as pi. And we talked about pi when we were looking at the chart. Pi is an irrational number. It is a real number. All the numbers we talk about, rational and irrational, are all real. So this number is irrational and it's real. You want to make sure that you are able to classify numbers using this chart. So again, this is a handy chart to put in your notes so that as you're doing your worksheets and studying for tests, you have it to refer back to. In class, we'll work on worksheet 3-2.